This is my video submission for my project for the MEDARVA Virtual Science Fair. My name is Will Richardson, and the title of my experiment is the effect of temperature on non-Newtonian fluids. Non-Newtonian fluids are a truly mesmerizing and peculiar part of matter. Shown in the background video, these strange fluids seem to take the form of a solid if it is pressured and liquid if left alone. But to understand these liquids, we must first understand what viscosity is. By definition, viscosity is a liquid's resistance to movement or change in shape. As shown here, water is a liquid with constant viscosity. It reacts to a change in shape the same way every time. Most liquids like milk or water are like this, but some are not. Shown here is a non-Newtonian fluid flowing out of a container, like a very thick liquid, but whenever it is pressured, it becomes a solid. This is what we call variable viscosity. This means the viscosity in this fluid is not consistent and is varied. Now that we know that non-Newtonian fluids have variable viscosity, let's move on to what we are testing. So we all know that when heated, a solid will melt and a liquid will boil. And when cooled, solids and liquids will freeze. This is basic science, but what we don't know is how non-Newtonian fluids react to a change in temperature. This is what I will be testing in this experiment. The way I will test this is once heated or cooled, I will drop a ball from the same distance onto a non-Newtonian fluid and count how many times it bounces. Before we begin, my hypothesis for my experiment is, if a non-Newtonian fluid is heated, then a ball will bounce one time if dropped onto it. Now that I have stated my hypothesis, I will explain my procedure. First, I will make a readily available non-Newtonian fluid in which I can make at home. It is a 2-to-1 ratio of cornstarch and water mixed together. I used 1 cup of cornstarch and 1/2 a cup of water for each of the 3 solutions. One solution will be heated, one will be cooled, and one will be the control at room temperature. Next, I will drop the ball from the same distance onto each fluid multiple times, examining the results and recording it with a slow motion camera. Once I have followed all the steps on my procedure, I will begin testing. First, we will go over the control group results. As seen here, the ball bounces 3 times before it settles and sinks into the fluid. After this video, I repeated this test multiple times and found the same results with 3 bounces each time. Next is the results from the cooled fluid. Once again, the ball bounces 3 times. I did multiple tests after filming this video and they were all identical. Finally is the heated results. As you can see, the ball only bounced twice in the fluid this time, even after multiple tests. From these tests, we can conclude how much the viscosity changed of a non-Newtonian fluid when heated or cooled. The amount of bounces showed if the viscosity increased, or got thicker, or decreased, got thinner. We know this because the ball will bounce more on a more solid surface rather than a less solid one. We learned that when heated, the viscosity decreases because the ball bounces less. Something I must note about the cooled results is that after a short time in the freezer, the fluid had frozen solid, but it still took as many bounces as the control. So cooling the fluid heavily increased the viscosity of it. Although the ball bounced the same amount of times, the cooled fluid lost its fluid state. From this, we now know that when heated, a non-Newtonian fluid's viscosity will decrease, and when cooled, the viscosity will increase. Now that I have my data and test results, I researched where this information can be applied in the real world. One use I found was that non-Newtonian fluids could be used in something like a bulletproof vest. If heavily researched and tested, it is a real possibility that there could be a bulletproof vest made out of a non-Newtonian fluid in the future. From my experiment, we learned how these fluids could react when in a vest if put under certain temperature conditions. Making bulletproof vests out of these fluids could be amazing because bulletproof vests made of Kevlar are expensive and hard to come by. Something as easy to make as a non-Newtonian fluid could be revolutionary for this product. Of course, this is just an idea, but now we know more than we did about non-Newtonian fluids than we did before. Thank you so much for watching, and this has been my project video on non-Newtonian fluids for the MEDARVA Virtual Science Fair.